Hello everyone. Welcome to my weekly stream about developing and live coding the Uno platform. My name is Jérôme Laban. I am the CTO of the Uno platform open source project. You can find us at platform.uno or on GitHub at Uno platform/Uno here. And I spend generally about an hour looking at issues, developing, working on new features, and poking around what the Uno platform does. If you're live with me now, you can ask questions. I'll definitely take a look, and we'll see what we can do. So today we're going to be taking a look at two features. The first one is something that was added recently in the Uno, the .NET runtime for WebAssembly. So Uno supports WebAssembly as a target, and the idea is that there's a way to get the build to go a bit faster. And there's an option that was added that's called -emit LLVM, -emit-LLVM. I wrote it incorrectly. And that feature is supposed to be making the build for WebAssembly applications that use WebAssembly generation, actual WebAssembly generation, go a bit faster. So we're going to take a look at where that goes and how fast that feature can be integrated, or if it does change anything. So when we're looking at that kind of issues, there's two things. I generally look at what the .NET team has been doing in their own repo, and then I try to find a way to get that integrated into the Uno Bootstrapper, so the code that allows for an Uno application to run on the web. So getting all the assemblies to run properly and get them integrated into your application. And it does quite a few things, additional things, like if you're trying to use a native assembly, for instance, or a native library, so Skia or SQLite or a few other libraries like that, then the Uno Bootstrapper is going to help for this. It's still not the same code as what the .NET team is doing, because we started off with something that was coming from the Mono runtime that was separate, and we were doing lots of different things at the time because the Mono runtime was not able to do what we wanted it to do. So that's why we have the Uno Bootstrapper. Eventually, we're going to get it aligned with what the full .NET runtime is doing. And they've been progressing quite well since for the past few months, but we're still not there yet. So that's why we're keeping the Uno Bootstrapper that we're going to take a look a bit after. So I'm going to search for that emit LLVM parameter that the .NET team has been talking about, and so I'm searching at the full runtime. So that is a large one, but the idea is that when we're invoking Emscripten, there's that option that's supposed to be doing something interesting. So I don't know if the search is going to have some impact. So maybe I'm going to try to search for something a bit more localized. So let's see if we go to Mono instead, and then WASM specifically, maybe we can find something interesting. Let's look into Mono specifically. Let's say we search not the entire workspace, but just that folder specifically. Maybe we're going to find something interesting. No, not emit LLVM is not giving me anything. So maybe it's a different parameter. Maybe they removed it. That could be. So we can try to find those in the make files. There are many make files that are used to build applications, but maybe we can find it somewhere in there in the WASM proj. So we search for LLVM, no LLVM here. So maybe we can search avoid compiling an LLVM code files with emit LLVM. So maybe that's the one that we're looking for. So we're searching for that specific parameter. So let's see if we can find it. So it's an src mono wasm build, So let's see. I think it's the one that I was looking for, but for some reason it's not appearing in the search. So maybe it's because of the search here. No. Maybe I need to move up a little bit. Or maybe I'm not in the right branch, or they removed it. That could be as well. Okay, so if we go to that file and search on the last version of it, is that thing still there? No, it's not. Okay, so it got removed. Okay, let's see why. So compiling native file. Okay, avoid compiling limit code with emitted LVM. So it was supposed to be after dgen pinvoke, so it got removed somehow. So it looks like it got removed. So let's look at the changes in between. Okay, so maybe if I look at the main and look again at the history, so we can find maybe the change that removed it. So it was here. Did that do anything? No. So it got added to WASM file native targets. Or maybe it was moved. And that's probably why I'm not looking at the right location. So it was added here. No, it really got removed. So it did look at the right file. So here it's not removed. That one didn't. Support mono runtime components, not here as well. Custom runtime native libraries. Okay, so it got removed here. Maybe it was moved somewhere else, or maybe because someone did something different there. So what's in the change? It feels like something that was changed. Feels like something that was changed unknowingly. Yeah. Okay, so that's an interesting one. So that parameter was removed, and if Zoltan added it, it was certainly for a very good reason, but it was removed in between. Okay, so what we're going to try is see if it does something to our Bootstrapper and not what the .NET runtime does. So let's open the Bootstrapper and see if we can add that to our test. So the way it works is that we have the packager. That's one part of the Bootstrapper that takes all the inputs that you have to get your application running, and then invokes many things like the AOT compiler from .NET, and then invokes Emscripten and a few other additional tooling that builds your whole application. And what we're going to do is find the location where that parameter needs to be added. So we got a dgen pinvoke. That one is generally present here. So it's available here. And we're going to add that parameter to see if that helps. So actually, we should probably be able to add it here. So let's add it here and see where that goes. So we're going to take that emitted LVM and add it here and see if that changes something in terms of the build time. So what we're going to do is just not update it for now. And we're going to take a look at the difference in build time. See if that changes anything. So for this, we enable the build logging and see, we're going to compare what the time is for building, let's say, the AOT Net 5 static linking. So that one is going to be doing some AOT compilation, and we'll see if that helps a bit. So let's rebuild this and see how long it takes to build that project. So if you don't know about that build logging tool, I'm probably talking about it every time actually. in most of my streams, or all of my streams. And it's a tool that's named Project System Tools. So that version is the 2022 one, but it enables to get very detailed information about the build and see where the time is spent, parameters of the build, and things like that, and troubleshooting many things that happen when building a .NET application. In that context, what we're interested in is the elapsed time for building the application. So see how long that one takes. So we can see here that there was a download that happened in between. So what we're going to do is we're going to be just rebuilding that application so we don't count the time for the download as well. Hey, Gisenko. Yeah, rocket science again, yes. Well, that's the kind of things that I do. It's not rocket. I'm not going to space like Bezos. But yeah. And playing games, not really. You know, that's my game. I mean, I like playing with code. So not really about playing games. So yeah, that's the interesting part. So if you like going to the weeds and into what WebAssembly does and what we're doing in details, that's the way to go. So we can see here that it takes quite a bit of time to build, and it takes quite a bit of time, and we're going to take a look at what takes some time. So it took about 100 seconds. So the download times is going to be minimal. So I think we can try to see what happens if we build that. So because I'm changing the Bootstrapper, there's a process that makes sure that the SDK that we're downloading is not modified. And because I'm modifying the Bootstrapper, if I don't disable the checks and validations to ensure that the SDK is the right one, the packager won't be updated. So we're gonna change that. So I'm adding that parameter, and now we're gonna see what happens. So to make sure that we're not having issues with the build. Let's see what that does. If I rebuild this, I'm probably going to be having some issues with deletion of the file. So that's an interesting one. It's actually Visual Studio that has a that locks the file. That locks the file that we're trying to build. And because we're building an MS Build target or an MS Build task, and we have to terminate the Visual Studio. The MS Build instances. So we're going to use taskkill to do that. There we go. So now we can rebuild. We terminated all the MS Build instances, and now the build is going to be working again. And let's see what kind of issues we're getting. So it says that the runtime cannot be downloaded. So that's probably because I'm having that issue. So let's rebuild it properly. So this is something that's needed only when being inside of the build for the Bootstrapper. So it's not needed in applications, but if you fiddle around that version of if you fiddle around with the Bootstrapper, you're gonna have to manipulate the SDK checksum validation so that the runtime is getting updated properly. It's something that I'm going to change, by the way, is if you go to the temp folder, here, come on, oh wow, being in 200 ratio is doing some funky things. So the runtime is downloaded here. And we're generating a checksum file that ensures that all the files that are there are the right ones. The problem is that we're copying the packager file here, and it changes. If you're overwriting it, then the runtime is going to try to re-download the Bootstrapper. Try to re-download itself, so that's not good. So that's why we have that parameter that prevents the runtime, the Bootstrapper, to re-download itself. So we re-download the SDK. Now we can take a look at the generated file and see if we're calling the Emscripten with the right value. So we're the Bootstrapper is generating a file that's called build.ninja. So it's using the Ninja build tooling underneath to generate everything that's needed for getting the application built properly. And what we're searching for is the emit-llvm parameter that's here. So you can see that llvm now is being called. Wow, that was fast. So how much faster is it? Okay, not that faster, but still, you know, it's interesting. So we went from about 108 seconds down to 92 seconds. That's not too bad. Now let's see if we can rebuild. If we do rebuild a little bit, so let's say we change that file and do just a build for that one. See if it reproduces in the same way. So we have if we have the same thing. So another thing that needs to be validated is that, you know, is that property doing something of interest, you know, or changing the behavior. So we're going to go take a look at the Emscripten documentation and see if that parameter is something that we can find some explanation for. Yeah, llvm is a bit too wide. So we're going to go on GitHub Emscripten directly and see if we can find some explanation about this. Okay, so not logged in on this one, so that's probably why it's doing this. Not logged in either. Okay, so we have a few locations where it's detailed, but not too many. So it's not particularly interesting. We get some make files that have it. No, it's not available there. So the problem is that the name is a bit too generic. So I don't know if we're gonna find something interesting about that. Yeah, even that with searching emit.llvm and it just said something else. Emscripten. Yeah, that looks like an obscure flag that only Zoltan Varga knows about. And I'm gonna have to ask him why that flag was removed. So no, it doesn't say anything much. And in the API reference, it's not there. If we search for just emit.llvm like this, maybe we can find something else. Emit.llvm. Yeah, not particularly useful. Okay, so we can try to, you know, let's go take a look because the search is not helping me there. I'm gonna clone this and do a search inside of Visual Studio. That's gonna be a bit faster. So Emscripten, and then we're gonna do a search in there. And maybe some more things that are interesting. So it could be that it's a flag that it's provided directly to llvm, and maybe it's not going to be useful that much. So we're going to have to look up into llvm to understand what that does, but yeah, let's hope not. So for the build, let's see, how long did it took? Pretty much the same time. So we went down from 108 to 92 seconds. So let's see if the application still works. If it does, that would be interesting. And it still does, so that's good. So that's some testing strings that are outputted by this simple application, and it looks like it's providing proper logging, so that's good as well. So now we know that that flag is doing something interesting. It seems to be driving down the build time, which is very interesting. And So have we cloned Emscripten yet? Yes, we have. So let's go and see if we find that emit LLVM parameter. Oh, there you go. What's present? Not too much, but still. Okay. So we have, come on. Okay, doesn't want to. So that looks like a Visual Studio 2020 bug, 2022 bug, because the box is going away. Gonna have to report that one. So bitcode objects, deprecate wasm files. There are many standard ways to enable bitcode objects. So we have emit LLVM instead. That's good. It looks like it's because the CMake is doing something in the back. Try to parse some content. Okay, so we have emit LLVM here. So it's emitting BC files instead of something else. Okay, you can see there's some tests about that as well, but not too many of the information. Maybe so it looks like it's something it's a parameter that goes down to LLVM directly or something that's underneath. So it's not going to be very useful. So it transforms the default extensions to something else. And okay, so not particularly useful. So now we're going to just validate that it actually does what it's supposed to do. We're going to be removing that line once again and see if we reproduce the build time difference that we had before. So just going to be stopping the rest again. And see if we have a difference. Oh, still locked for some reason. Okay. Oh, no, it's the, okay. That's IIS that's still running, so I have to terminate IIS as well. Okay, there you go. So IIS is killed, and now we're going to be looking at this and see if that goes farther. So if that helps, that means that for larger applications, we're not going to spend too much time recompiling things around. So I'm going to be pushing that update. And if you're using AOT, that means that it's going to help for building applications or decrease the build time. So that's good. Okay. So it's still building. I'm going to get the results in a few seconds. Next, we're going to take a look at another issue, which is something that was reported by Enterwood. And that's adding a custom resource dictionary to application-wide merge dictionary doesn't work. So we're going to try to validate what that does and trying to fix this. It's a seemingly easier one than others, so we'll see what happens. So if the build takes around, oh yeah, I need to. So I see I forgot to remove the SDK, to add the SDK workaround there. So that means that the build is it's not going to be using the right binaries. And to see that, we can see that in the build.ninja, we're still going to get the emit LLVM parameter. And even though we changed and rebuilt. So the way to change this is to ensure that the Bootstrapper is going to be overwriting everything properly. And we can just rebuild that one, and that will do. So now we can just validate that the build.ninja is having the right content. After a few seconds. LLVM, so we need to close and reopen the file. Emit-LLVM is still here, so it's not overwriting the file for some reason. Probably I missed something, or my branch is too old. Another way to do this is to ensure that we delete the SDK folder. So we're going to be removing that one. So we're still Clang, so we can kill Clang. There we go. So we're going to go to that folder here and drop the runtime so it gets re-downloaded. And we're going to be rebuilding this. So in the meantime, we're going to download the project that was for the other issue. And we're going to take a look at that, what that application is doing. So it's 6399. And let's take a look. So we have another Visual Studio instance to test all this. And we're going to do this in here for now. Okay. So we're going to try to see if the repro is actually doing what it's supposed to do. I hope it does. So the issue is explaining that if there's a resource file called my theme that contains test font size, UWP says that the hello world is in large text, and GTK head says that text font size is not at the right size. Okay, so let's validate this. So the Bootstrapper is still not finished. Oh yeah, I have to change something first. I think it's sources there. Yeah, there we go. Because the file has been downloaded from the browser, and the files are locked, and which Visual Studio is looking for. Okay, let's open that one again. Nope, not that version of Visual Studio. And then we're going to take a look at the UWP application and see if it behaves the way it should be. Okay, so the Bootstrapper finished, and it took 108 seconds. And if we just save that file and rebuild again and see how long it takes. So if it improved from 100 and something to 92, it's a good improvement. Okay. So if I open the UWP application and let it run, so let's go and see what happens. So Bootstrapper is still running. So what we need to take a look at is likely to be in the app.xaml, which references a my theme XAML file, probably. Or is supposed to be. Okay, so there's a local.mytheme here, and it looks like it's not handled properly. Okay, so we have hello world in large font, and that happens because local my theme is detected, and it's a resource dictionary it's a resource dictionary that needs to be imported directly. So it's supported by default because that one is something that we handle properly. But it looks like that one is not being generated for some reason if it's not running. So let's see if we open the GTK application, for instance. Do we see the right content? Okay, so it's too small. So that means that for some reason that line is not imported properly by the application, and the size is not the right one. Okay, so the download took about 2 seconds. So that means that we're going from 105 seconds down to 92 seconds, which is pretty good. That's pretty good considering the time it takes for many other things. So that means that it's a feature that we're definitely going to be adding to the Bootstrapper, so that larger applications take a bit less time to build. In general, if you have a larger application, it can take about, let's say, 5 minutes to build because of AOT generation for various reasons. And I'm probably going to ask again to see why that parameter was removed. Okay, so now let's go back to our XAML file. So now what we want to find is why is this line not generating anything or not being taken into account. So to find this, we can go to the opt folder. If so, in here we're not having the right content generated. So there was a question that was asked, I think it was earlier today, about where are the files that are generated by, if you have a XAML file, where is the code that's generated for it? Depending on the target, if you're on iOS, Android, or Mac OS, for the current version of Xamarin, the files are generated in a folder called G in the opt folder. But if you're on GTK, those files are generated by Roslyn, and you can find them in the analyzer folder. So in here, you can drill into analyzers and then try to search for UNO source generators. And then there's a node that's called XAML code generator. And then you're going to find all the generated files here. So if we open that file, we can see here that there should be some content here. So we can see here, merge dictionary add. But the interesting thing here is that it's adding an empty dictionary. That's an interesting one. So that means that if in app.xaml we have a file like this that's invoking something that's called my theme, which really is a resource dictionary, we're not looking for the fact that the resource dictionary has an X-class attribute and trying to use that one instead. So what happens is that we basically create a resource dictionary that's not the right one. So it's not, there's nothing's happening. So we're going to try to debug that. And to do this, we're going to open the UNO solution and try to debug that. So let's go for UNO. So when you're opening the UNO solution, you need to go and open the file that's called cross-targeting override.props, which you can generate through the props.sample. You basically copy one to the other, and then you can adjust the content there. So we're going to be opening the solution using a solution filter here, and the one that we're going to be using is the Skia one because we're debugging a Skia head. Not that it changes too much, but it's going to help for overriding the UNO version that's used by the application. So we're going to take a look at which version of UNO is used, and here it's 3.8.11. So we're going to be updating that one to a more recent version. Preview generally, so it's easier to override. And we're going to be using the 3.9.3.5.8. So the reason I'm doing this is that it's easier to override a preview version than a stable version. Most of the time we don't change that. We generally update the preview because it's easier. And I'm just going to take that version and now back into the, looks like that one wasn't dated, so let's update that one as well. And back into the UNO solution, we just update the version here, the UNO NuGet override, to use the right one. And then we're going to open this solution so that we can go and build the source generator. So the source generator is in the Uno UI folder. And then we can find here the generator available there. So what we need to find is the location where we're generating that code. And most of the time what I do is I take a string that's pretty generic, like that one, and search for that in the generator source. So yeah, so that's the large file that's called it, that is the generator, and we're going to try to find the resource dictionary. So it may not be that one, so it could be another one. Nope, not that one as well. So resources probably is a different one. So it looks like we have a comment that's called merge dictionary, so we could probably search for that one as well. Let's see. Not here either. Not here either. Or maybe I'm not searching for the right content. Could be. Let's see if we can find it somewhere. No, it's not here. So it could be that it's an actual property that's generated, and that's why we don't see it. We don't see it properly. So it could be that it's generated differently. So we're gonna have to search differently. So let's take a look in the generator to find for resource dictionary. Resource dictionaries. Yeah, let's search for a resource dictionary that way. And so we got build resource dictionary backing class, build top level resource dictionary. So that one is when we're actually compiling a top level resource dictionary. So that's not the one we're looking for. I get top level dictionary. So we got a theme dictionary. So we're in the top level resource dictionary again. So that's not the one we're looking for. Top level resource dictionary. So that's not the one either. A registration for default styles. Not necessarily that one either. Initialize and build resource dictionaries. So resource dictionary subclass, resource dictionary. So that would be, so that's for other type of dictionaries and not that one either. Okay, so let's search for it differently. Let's go for drawables. I'm going to search for that one. So we have register and build resources. That one's easier. So for the flow, we get into the resource dictionaries, and then we try to find resource members. So we got the resources here. So if we have a member that's called resources, then we're going to build the resource dictionaries here. And then we have resources, and then new for the globalized file. We have resources as well here. Okay, so let's try to find the one that makes sense. So there's a loop for merge dictionary, theme dictionaries, and resource dictionaries. So the one we're looking for here in the app.xaml is it's an actual resource dictionary. So get source here. So that would be build dictionary from source. So we got append line invariant resources equal. Is that the one that we're looking for? That's not the one. So that would be another one. So I don't know, and then we're gonna have to go and debug where that is. It's somewhere in there, but I don't know which one that is. So the best way to do that is to enable the debugging. And just going to place a breakpoint so that we find that one properly later on. And there's a file that there's a property that you can set here that's called Uno UI source generator debugger break. That will basically ensure that the debugger pops up when we're building the application. So we just need to add that one here at the top. Set it to true, and then when we build the application, so we need to build the source generator first so that we use the right version. So we're going to be overriding the version, that version specifically. So if we look at the source generator here, we can see that the override was done here. So 39358. That's the version that we're going to be using. So now if I rebuild the application, we're going to have the debugger pop up. We open a second version, a second instance of Visual Studio, and then we're going to be adding a breakpoint to the location we were before, which is register and build resources. I don't think it's in that file, so we may have to open it. So let's copy the path for that one and open it in the debugger instance here. I could have chosen probably should have chosen the Uno UI solution instead of opening a new one, but still. It's not changed. So let register and build resources. And let's see what we can find. So if we let the build run farther, just to the top level control is the application. So that's the right one. Application, that means app.xaml.cs, and that's the one that we want to see where the code is generated. So we got the resources member. We do have explicit resource dictionaries here. We have no resource root. We have merge dictionaries. Yes, we do have a merge dictionary. Do we have theme dictionaries? We don't. We don't have a source. We don't have a subclass for that one. So we're going to this one. Okay. There's no initializer, so that means that we're going to be building the merge dictionary. So, so if we take a look back again at the application, we're going to be looking at merge dictionaries specifically. So let's dive into this one. Then we're going to be building a dictionary collection. That's where we add the merge dictionary writer. So that's the comment that we see here. That's the comment that we see here for the merge dictionaries. Which is good. Then let's dive into individual dictionaries. So the first one, there's no source. It's not a key dictionary. 99% of the time would be null. That looks like a comment done by David Oliver. So it's not initializer and is dictionary. I'm not sure. So we're creating an add, and then we're now building the resource dictionary from source, or from the initializer. So that's the first one. So that's the first dictionary that we're looking at. That's not the right one. So let's skip that one for now. Closing the code for that one. And then let's look at the second one. So the second one is not the right one, and it's not built properly. So we're adding the same line. So we're adding the same thing that we did see here. So we're talking about that line. So we're adding the merge dictionary, and then we're moving to the initialization. There's no source, so we're building the dictionary again. So is the resource dictionary a subclass? So I don't know what that means. So if the XAML type name is not a resource dictionary, but is the type is a resource dictionary. Oh, that's interesting. So that's probably why. So that would be because the resource dictionary that we have is not a subclass or not detected as a subclass. So we should be getting that defined properly, but we don't. And I see why. I see why. So it's something that we haven't done. And that's caused, seemingly by the fact that Roslyn is behaving in a certain way. But if we take a look at the code that's generated by the application, so let's go take a look at that. So it's building quite a bit of stuff. We can remove the debugger break now. Okay, so the way the theme is declared, as you can see here, there's no resource dictionary. So that means that this class is known by Roslyn when it parses the source for the current application. But because there's no definition, there's no resource dictionary here. Because there's no resource dictionary defined here, what that means is that the mytheme class is not. So when Roslyn parses the file, parses the sources that are known during the compilation, mytheme does not have a base class. And the base class is actually, we can go take a look again at that one. So if we rebuild the application, we're going to go take a look. So that file, that class doesn't have any base class other than object. So if we go and put a breakpoint, here actually. So that's top level control. So in here we have the top level control here. So the type here that we have is XAML control resources, and the second one that we get is mytheme. So now if we dive into that, and that is resource type, we're going to go to the is resource dictionary. And the problem here is that is resource dictionary is invoking a class that is called isType. And so if we dive into isType multiple times, we're basically going to be finding a Roslyn type. So that type is a Roslyn symbol. So you can see here it's an I-named type symbol. And if we take a look at the base class for that one, if we can access it, and the debugger lets us do so, because there are many properties, and that's probably why it's not giving us anything. There we go. If we take a look at the base class, it's probably available somewhere in there. Oh, that one's heavy. Containing, that's not that one. Do I see base class here? It's probably on the I type, say base type. So the base type is available here, and the base type is object. So that means that when we're trying to determine if the type that we got from the XAML and we resolved it using a string, we get a type for which the base class has not been defined yet, because the definition of the base type is provided through the X class that is here. So it's something that we haven't fixed yet, and probably should be doing something to work around it to help there to, let's say, maybe provide a set of classes that are known, or say that if we're trying to find a class there and then it's not known, we should be looking into XAML file, or let's say generate a set of files. So we parse all the XAML files, and then if we find an X class, then we generate some kind of a stub file partial that has the right inheritance, so that the lookups afterwards don't have a problem. So the easiest way to fix this is to actually specify the type. So let's cancel this for now because the build is not very useful. So if we go back to my theme here and then we do resource dictionary and rebuild the application, actually we should not have to rebuild the application. I think the generator is supposed to be running automatically and pick up the updates. So let's see if it actually happened. Oh, there you go. It's been updated automatically. So it worked. So there's a bug for sure. And the bug is that it's not specific to resource dictionary. It's actually more global than that. Is that if you don't define the base type in the file when you're only referencing it from here, then Roslyn doesn't know about the fact that the class here is supposed to be inheriting for something else. So the workaround is easy, but how can we fix this? So we're doing already a few things with Roslyn to kind of trick it to know a set of class that don't exist really, so just to make sure that we're able to have some sets of known types. So it's a bit obscure, but let me show you. So if we go to, there's a class that's named Roslyn metadata helper, which is actually a bigger class that's not really metadata helper, but it's something that manipulates a lot of things around creating compilation, getting the semantic model and things like that. What I don't know is that I don't know if we can rebuild a compilation from the first one. So let's take a look. We have a set of metadata here. I don't know if we can generate an additional one. So we have something here that's called generate additional types map. And I don't know if we generate something additional there. So that map is supposed to be building existing types from new ones. Get declared symbol. So we get additional types tree. We get original symbols, and then we try to get additional ones. Yeah, that's not the right one. So probably we can find another one. So we get build legacy type. That one is just getting metadata, so that's not the one. So in the generators, we have two ways to build types. The first one is by getting we get types only known by getting the compilation that we have here, or we can create a newer compilation by adding additional sources and get a new compilation. But I don't know if we can create a new compilation based from an existing one with only the APIs that we get there. So let's see. We get compilation here. Yes, we can create new compilations. Okay, so that would be something of interest there. Compilation, I don't know if we recreate compilations here. No, we create one and we stop there. So what we should be doing is parsing all the files and then creating a new compilation based on a set of additional files that we parse, that we have to give to the compiler, and so that it knows about the generated files. I get Same, maybe. I'm sorry if I'm butchering your name. Is it possible to make a code to press down two keys, like press 1 for 10 seconds, then another after 10 seconds? To press down two keys, like press 1 for 10 seconds. I'm not sure what you mean by that. Is it you want to emulate? Is it for UI testing? Is it Is it for an application for simulating things? Is it what's the intent there? So for that Roslyn metadata stuff, we need to adjust something. Let's see if we could probably do something different. So let's say I have a compilation there, and we're going to try to add an additional file and see if we can get something there. So let's say I do add syntax tree. That looks like we can. And we can have a syntax factory. And we have there's a create, if I remember correctly. Maybe from something, from clause, no. I don't remember the syntax. I think we do have that somewhere in the solution. Let's see if we have some. Not here. Oh, I think I remember where I put it. I used that in the Sharp Fiddle tool that I built. So let's go take a look at that one. Syntax factories. We have parse compilation unit. Okay, so let's do this. So parse compilation unit. And then we should be able to parse some text. Okay, so if I do something like my test 01, and I say that my compilation here is done that way. So it wants a syntax tree, and I'm not having a syntax tree. So probably there's a syntax. Yeah, there you go. So we have a syntax tree here. And then I have a compilation. So I've modified my current compilation to add a new set of syntax tree. So if that parses properly. So that means that in here, if I add this here, I should be having something like, I should be able to get from the compilation, I should be able to get my test 01. Compilation, get type metadata, get type metadata by name. And if we do my test 01, I should be having that available. So if I rebuild this, and we're going to jump into the debugger and see if we get that. So let's spawn off the debugger again. This time I'm going to be attaching to the right Visual Studio and not another instance. So I'm going to be using the Skia only one, so that we have all the IntelliSense that makes sense. Okay, so if I go back to the Roslyn metadata helper, if I put a breakpoint here, does my type? Yes, it's available. Okay, so that means that I have injected a kind of a virtual file that doesn't exist anywhere, but just here. And Roslyn was able to parse it. And that means that from now on, from that compilation, I can get all the types that I need and provide those to the rest of the code if need be. So that's interesting. So that is a very useful part. So let's stop the build for now. So let's go find where that Roslyn metadata helper is built. So it's available at that location, and we're building it quite late, actually. That means that we're not having, we have not parsed the XAML yet. And we get the files here in XAML source files, so we don't have that parsed, and we're parsing that later on, actually. So that means that we don't have the right metadata available at that time. So what should we do? What should we do? So multiple ways. We could probably parse the file ahead of time. just to find X names or X class and try to just add types where needed. But that may cause some additional issues because we don't have all the information available right away. So let's see. That is called from the generator here, and then we have a generate method. And that generate method here is calling the file parser. And we're parsing all files. We're parsing all files, which I just saw that we're not doing in parallel. Oh yes, we're doing it in parallel. Okay, so we're doing it in parallel. So what would be interesting is we should be creating the Roslyn compilation after that parsing here, so that we get access to all the information about the types that we got from the parsing of the XAML file, and then we can provide that to Roslyn. So let's see. Let's see if we try this. Let's say that we move the metadata helper. I don't think we're using it too soon. We're using it for the parser. So that's a problem. So that won't work. So that won't work this way. So that means that we need to do it some other way. So we're giving it to the XAML file parser. So that's a problem. So why do we use it? We use it to say if a type is present or not. That works. Okay. So we're doing this very early, because we're doing this through the XML document, which is definitely too early to get some parsing available. So it's not particularly useful there. Okay, so that may be a bit trickier to fix, because the Roslyn metadata helper has some information that's needed by the XAML parsing, but the XAML parsing needs information that's available in the metadata parser. So it's kind of a chicken and egg problem here. So we probably need to, I think we're going to be having to split the parsing in different parts. So when we look at the parse file, the parse files and parse file, we're using a XAML reader, but we're doing it from an XML reader. So I wouldn't want to parse the file twice. There's an apply ignorable. It's done beforehand. It's done beforehand. So we're getting an XML reader document. It's an XML reader document that's built from a string reader. Interesting. Okay. So we're reading the files. We're reading all the files one by one by strings, then parsing them. Yeah, that makes it for some interesting rewriting to be available there. So another way to handle this would be to add types after the fact. So let's say if I go back to the Roslyn metadata helper, most of the things that we're doing are about finding types and doing some lookups that return something or nothing. And the problem is that if we're doing some lookups that don't find anything, then we have to clear the caches and build them again as we add new types. So that doesn't work. That doesn't work either. So we're probably going to have to refactor a little bit of the structure of the generator here to be able to add additional types that may not be known at runtime, that may not be known at compile time. So the workaround for now. So another way that we could do this is to say, if we could probably emit a warning. That would probably be easier in the meantime, so that people do know about this. So let's say, yeah, let's do this that way. If we have a source generator, if we have a file that has a class, so let's say if you have a file here, so it's an Uno app there. So you have a XAML file here that is inheriting from something. So it has an X class and it's inheriting from a resource dictionary. And that in the C# file that's next to it, you don't have the base type. So the base type doesn't match. We should probably mention that as a warning. So let's say if the base type is not the right one, then you need to add that so that the code is going to be working properly. Yeah, we should probably be doing this. So I think we've dug into that code pretty deep. So the fix would be, well, not the fix, a potential heads up for there may be an issue and you need to add something to your class so that the definition works properly. Is that if we detect the discrepancy between that class that's in the source code and the same class defined in the XAML and the base class is not the same, we're going to emit a warning. So we're going to be doing this probably next week or beforehand if we find additional things that need to be adjusted. Okay, so that's it for today. I hope you liked the deep dive into Roslyn and generation, as well as the fact that we got some interesting performance improvement with the source generation and .NET and .NET for WebAssembly. So if you're interested in WebAssembly AOT, you're probably going to be wanted to take a look at the next version to see if that improves your build time. So give me a follow if you haven't done already, and on Twitch, and then see you next week. And since then, happy coding. Bye for now.